Okay guys, this is going to be a video recording for physics class on the topic of unit conversion. Sometimes students have trouble with unit conversion, and it really shouldn't be that big a problem if you just follow a few basic steps. The reason you sometimes need to do unit conversion is to make units match, or to make your answer match the question that's listed. For example, let's say a basketball player playing in the Olympics is listed in the program as 178 centimeters tall. If you're not used to the metric system, you might want to convert that over to different units that are more familiar to you. So the first thing we're going to do is try to eliminate this prefix. What does centi mean? And there are tables for metric prefixes that can be found online and in your textbook. And the way we set up unit conversions is we want to write a fraction equal to 1. And we want to arrange our unit conversion fraction so that we cancel out units that we don't want, and we end up with units that we do want. So we're trying to get rid of centimeters. We don't want the centi in there. We just want regular plain old meters. So what you need to do is look up what centi as a prefix means. And in our textbook, it tells us 1 centimeter corresponds to 10 to the minus 2 power meters. All right. So one way we could set up this unit conversion is so that the centimeters cancel out and we get meters for an answer. We're going to have 178 times 10 to the negative 2 power for our answer. At this point, I'm going to go to our friendly calculator. Where did my calculator go? To try to help us find the specific answer. So, in our calculator, if we type in 178 times 10 to the negative 2 power, our calculator tells us that's equal to 1.78. So I can come over here and write this answer as 178 centimeters is equal to 1.78 meters. So that's nice. Now we have the height of the basketball player in meters. But do you really know what that is? Probably not. So we need to make a change from meters into a unit you are familiar with. We want to get rid of meters, so we put it on the bottom so this will cancel. And the units that you're used to using are feet. In our textbook, it gives us a conversion factor. It tells us 1 meter is approximately equal to 3.281 feet. Right? The way we have this set up, our meters are going to cancel out, and our answer is going to be in units of feet. So let's go to the calculator and take 1.78 times 3.281. And it tells us this basketball player is going to be 5.84018 feet tall. So between 5 and 6 feet. Suppose you want to be a little more exact than that. Well, we know we can write out the 5 feet separately, right? So let's just change the decimal part of this answer into inches. To do that, I'm going to come down here and leave off the 5. Just write the 0.84018 feet, and I want to change units to get rid of the feet here and get inches for my answer. How do feet and inches compare? Most of you know 1 foot matches 12 inches, right? So if we take just the decimal portion, 0.84018 times 12, we could put in the divide by 1, but we don't need to. It tells us this player is going to be a total of 5 feet and about 10 inches. So we started with 178 centimeters in an Olympic program, and now we've changed it over to 5 feet 10 inches, which most of you have a pretty good idea of how tall that is. So unit conversions are not supposed to be a terribly complicated process. You write down the measurement that you start with, and then you write a fraction equal to 1. And you want to write the fraction such that the units you want to eliminate will cancel out, and the new units that you want will carry over. We did the same thing on the next step. We started with meters. We want our answer to be feet, so we have to write a fraction equal to 1 that eliminates meters and gives us feet as our answer. And then we started with feet, and we wanted to change it to inches, so we have to write our conversion factor to divide out the feet and give us the inches that we need. Unit conversion is not supposed to be complicated. Okay, let's do another calculation for a unit conversion, just for practice, make sure everybody understands. Suppose we've got an athlete who can run a distance of 100 meters in a time of 9.6 seconds. Now that's Olympic speed. That's really fast. How many miles an hour is that? So let's see if we can work out the pieces for how to set up the unit conversion to change meters per second into miles per hour. Somehow we're going to have to figure out how to change meters into miles. Well, we had a conversion factor for meters that we used on the previous problem. What was it? It said 1 meter is approximately equal to 3.281 feet. So let's use that one. If we're trying to get rid of the meters, where are we going to write meters in our unit conversion fraction to eliminate the meters? If the meters start off on top and we want to get rid of them, we have to put meters on the bottom, right? 1 meter was equal to 3.281 feet. So that will cancel out our meters, and now we have feet per second. But that still doesn't match miles per hour, does it? Now we have to figure out how to change feet into miles. You might know the conversion factor for how many feet are in a mile. You might actually have to go online and look it up. How are we going to arrange the units for our conversion multiplier? We want to get rid of feet. Since feet are on the top, to get rid of them, we're going to put feet on the bottom. We want miles to be on the top for our answer, so we're going to have to put miles on the top of our conversion factor. I know that 1 mile is 5,280 feet. If you didn't know that, you could look it up. So now by using this fraction, we can cancel out feet, and we will have miles, which is what we want as the top part of our answer. But what do we have on the bottom? Do we have hours? No. On the bottom, we started with seconds. So somehow we've got to get rid of those seconds. What do you know about seconds for time? Usually somebody says, I know there are 60 seconds in 1 minute. So we can start off with that. If we have seconds on the bottom and we want to get rid of seconds, where are we going to put the seconds in our conversion factor? To get rid of what's on bottom, we put it on top. If there are 60 seconds in 1 minute, this will cancel out seconds. And now we'll have miles per minute, but we don't want minutes. What do we want? Hours. So we need to set up another conversion factor. To cancel out the minutes on the bottom, we're going to have to put minutes on the top. To get our answer with hours on the bottom, we're going to have to put hours on the bottom. How do minutes and hours compare? 60 minutes in 1 hour. Now our minutes will cancel out our minutes, and we will have miles for our answer, which is what we wanted here. So now we just need to go to our calculator and type all of this in. So we start off with 100 meters in 9.6 seconds. And we're going to multiply by the second fraction, 3.281 feet and 1 meter. And then we're going to multiply by the next fraction, 1 mile divided by 5,280 feet. And then we're going to multiply by the next fraction, 60 seconds divided by 1 minute. And then we're going to multiply by the last fraction, 60 minutes divided by 1 hour. And when we put all of that together, we end up with an answer. If he can run 100 meters in 9.6 seconds, that's the same as approximately 23.3 miles per hour. This example is like an Olympic sprinter. It's almost a world record. Usain Bolt can run about 23 miles an hour. Does that make sense to you? Have you ever ridden in a car that's driving 23 miles an hour? It seems awful slow, doesn't it? Well, here's what you can do after school today. Find an empty road. We've got lots of empty country roads around here. Stand behind a car. Don't latch yourself to the car, just stand behind it and have the person start driving. And run and see if you can keep up. When they get up to 23 miles an hour, see if you can keep up for 100 yards or 80 yards, the length of a 6-man football. Nobody at Highland is going to be able to keep up over very long a distance at 23 miles an hour. When you're running, it's extremely fast. When you're riding in a car, it seems slow. But that's Olympic class speed. So this is how we do unit conversions. Some of the unit conversions are simple one-step calculation. Some of them may take 5 or 6 steps to complete the answer. But the process is always the same. Set up a fraction. Set up the fraction to eliminate the units you don't want and give you the units you do want. And continue the process until you have the units for your final answer. You will get extra practice at unit conversions for your textbook homework, and you will have extra problems online to work on. And if people have a lot of trouble with this during class time, we will make up extra examples to work on the board as well.